to ACI, the Network Made Simple learning series. In this video, we will cover Module 3, Configuring Logical Connectivity, Chapter 2, Putting it all together, Connecting VMware and Bare Metal in Minutes. So far, we have covered the physical and logical network configuration steps in different chapters. So, it is time for us to put it all together and show in a scenario how to go from zero to connectivity using everything you've learned at this point. Our objective for today will be similar to what you will be facing every day, connecting two different groups of servers together, in this case web and database ones, which are running on VMware and physical environments, and then make sure that we secure these communications by only allowing ICMP and port 544 on the database side. With that being said, I will be going through every step as we learned in our golden questions for both the physical and logical network configurations. I won't be as detailed this time since you already know what we are doing. Feel free to go back to previous videos if you need a refresh on any of these steps. Our topology looks as follows. We have an ACI network currently in place, and we have two VMware ESX servers running on two different UCS clusters, both with fabric interconnects which will connect to our Leaf 101 and 102. ESX1 is running on a regular UCS blade system which is connected to the ACI leaf layer through an LACP port channel, and ESX2 is running on an UCS mini blade system through a single link connection to our ACI network. We also have a couple of Nexus 5000 legacy switches with VPC configured on their side, and we will connect them to the ACI network using VPC as well on the leaf side, in order to have a dual-sided virtual port channel configuration. The web EPG will have the 1110 network, and the database EPG will have the 2220 network. We will use ACI Anycast gateway for each network, using 1111 and 2221 for the web and DB bridge domain subnets respectively. In the case of the web EPG, we will extend it to the Nexus 5K connection, since I may have some legacy web servers behind it. I have already configured an IP address on the Nexus 5K pair using HSRP with IP address 1111100 and with a default route to the ACI Anycast gateway as well. Are you ready? Let's start with the VMware vCenter and the ESX servers first. I'll first create the VMM domain using VMware's VDS. I will need a dynamic VLAN pool, and I will create an AEP called production to glue all this together. Since this is a VMware VMM domain, I will need to create a trust relationship with vCenter. So I will provide my credentials, the vCenter's IP address, and data center where I want this new VDS to be deployed on. And since I'm using UCS blade systems, I will also specify MAC pinning for those servers which may have more than one VM NIC. And lastly, I will enable CDP. Okay. We're done now with steps 1, 2, and 3, and our integration to vCenter is done. We can see that the newly created VDS has now been deployed. Let's now add both ESX servers to it using VMNIC1 for the UCS base one, and VMNIC2 and 3 for the one running on UCS Mini. Okay, we're done. Now, we need to perform steps 4 and 5 for both UCS environments, right? We will be creating a port channel for the UCS base system, and then we will be creating an access port for the UCS Mini. In order to make the recording shorter, I will only go through the configuration to connect to one fabric interconnect. However, you will see the end result, including both fabric interconnects for both UCS systems, at the very end. Let's create the port channel first through the wizard in the Fabric and Access Policy section. We select the leaf that we want to configure, the interfaces, in this case E1, 17, and 18, and I will adjust the names for the switch and interface profiles in order to comply with the naming convention we learned about in the Best Practices chapter. I will now specify this is a port channel connection, and finally, I will create the port channel policy group, which will have CDP enabled, LLDP disabled, LACP active, and of course, our production AEP we created before. And we're done. Let's now perform the configuration for the UCS Mini connection to the Fabric Interconnect A. I'll do it this time using the step-by-step approach, and we will reuse the same switch and interface profiles that were created in the wizard. First, I'll create an access policy group enabling CDP, disabling LLDP, and also adding my production AEP. Then I will go to the interface profile that was created by the wizard previously, and I will simply add another port selector, now including E111, which will use the access policy group I just created. And we're done, since the switch profile is already associated to the interface profile, as you may remember. Let's now verify how everything looks for our UCS and UCS Mini Fabric interconnect connections to ACI. As you can see, we have two switch profiles, one for each leaf, and their corresponding interface profiles created and associated. We can also see all three interfaces configured, two as part of the port channel and one for the single link connection to UCS Mini. And we can also verify everything is up, either by checking at the topology view, or we can also log into the CLI and check the status of the port channel with the traditional commands. Looks like we are done with the VMware servers. Let's now move on and configure the physical network for our Nexus 5000 switches using the step-by-step approach. We'll start by creating our physical domain. We will add a static VLAN pool with the VLAN I will want to trunk, which in this case is 2143, and I will use the same production AEP I created previously. Then, since this is a VPC connection, I want to make sure that I have a VPC pair ID set up between leaf 101 and leaf 102. Otherwise, you will have to create one. In my case, it seems I already have it, so we're good to go. Next, I will create my VPC policy group. I will enable CDP and LLDP, will assign my production AEP to it, and will set LACP to active. Done. Then we will need to create a separate switch profile and interface profile for both switches, since this is a VPC pair. I will define my switch profile including leaf 101 and leaf 102, and will create its corresponding interface profile, which will have interface E131 as part of its interface selectors, which I will assign the VPC policy group to. And we're done. We now have three switch profiles and their corresponding interface profiles associated. If we go to the CLI now, we can also see that the VPC is up and running. Great, we have finished the physical configuration, so let's move on to the logical one now. First, we will create a tenant and a VRF, which will be called myTenant. Then, we will do the EPG, bridge domain creation, and VMM association slightly different, since we will be using the multi-tier wizard this time. I will add a name to my application profile. I will associate my VMware VMM domain to test communication between VMs first, and will create a couple of EPGs with a bridge domain each, which will have a subnet to perform as Anycast gateway in both cases. And we're done. As you can see, the wizard is simplifying all these steps for you. Still, all the necessary objects as we learned before are being created. For example, if we take a look at the contract that was created for these two EPGs, we can see that all traffic is being allowed, as the filter is unspecified. We would be done by now if all you needed was connectivity, but in our case, we care about policy. So I'll go ahead and modify the filter created by the wizard so that we only allow ICMP and the database port, which in this case is TCP 544. Let's now test our VMware environment. We will first go to the web server VM and assign its network connection to the web EPG that was automatically pushed by ACI. We will do the same with the database VM this time, assigning it to the DB EPG. Let's see if they have communication one another. And they do. As you would expect, they can also ping their default gateway, which is any leaf in the ACI fabric behaving as Anycast gateway. Now, let's log into one of our legacy Nexus 5000 switches, where, as you might remember, we have established a dual-sided VPC connection to our ACI fabric. Currently, the N5K pair has HSRP running between them. In this case, the real IP for the N5K-A switch is 111.101, and it can't ping the Anycast gateway IP address as expected. Let's go ahead and fix that in a few seconds, since most of the work is already done. I'll go to my application profile and simply drag and drop the bare metal icon to the web EPG one. I will instruct ACI to assign to this EPG any traffic coming from the VPC to the N5K, which is tagged with VLAN 2143. So, to make it simpler, if it is VLAN 2143 and it comes from this VPC, That means it should be classified within the EPG web server. Easy, right? Let's go back and test that connectivity to the Anycast gateway IP again from the Nexus 5K. And it works. What about the rest of the VMs? Well, we obviously have connectivity to the web server VM as it is in the same EPG, and also to the database server VM since we already have established a contract in place which allows ICMP. I created the configuration once, and now I will be able to use it multiple times, as you can see. And what about VMs in the UCS mini environment? Well, I have a new web server now running there. And as you can see, all I need to do is assign it to the right EPG or port group, and the same rules apply. Well, we're done. Everything has connectivity at this point. If you decide to make any changes down the road, for example, remove ICMP from your policy, remember those changes will be simultaneously applied to every leaf that is using it, removing the need to configure or modify anything on a per-device basis and keeping everything consistent even if a VM moves at some point. Let's put ICMP back in our contract and call it a day. Some of you may be curious to know what happens in terms of packet forwarding, or maybe learn some useful commands that can help you troubleshooting. So, if you're interested, join me in part 2 of this episode, where I will be providing a quick overview of what is happening behind the scenes in terms of packet forwarding, as well as some useful commands that you can use to verify endpoint learning in ACI.